User interfaces that adapt to the user's context can prevent usability breakdowns, thereby improving the user experience.
Enable optimization.
Creators can struggle with the implementation of adaptive user interfaces because existing tools are underdeveloped to support realistic extended reality settings, where it is often necessary to consider conflicting aspects that affect an adaptation. We fill this gap with AUIT, the Adaptive User Interfaces Toolkit for designing extended reality applications. Creators can use our toolkit to combine adaptation policies that address common objectives in extended reality, such as reachability, visibility, and learnability. AUIT provides a clear separation of concerns for creating an adaptive user interface through 5 design concepts that we introduce as follows. Adaptation objectives describe adaptation behaviors to address, such as visibility or ergonomic aspects. Consider a virtual element we would like to adapt, in this case a hologram. For it to be in reach of the user, we start by adding an adaptation objective to position it at a specific distance interval. However, this does not mean it will always be visible to the user, so we add another objective to place it in the user's field of view. Finally, we avoid collisions and occlusion with another objective. Solvers are the algorithms that combine adaptation objectives and compute adaptation candidates, resolving conflicts if necessary. As there are many ways an interface can adapt, the solver proposes a suitable candidate when possible. Context sources process raw sensor data into higher abstraction levels to inform adaptations. Adaptation triggers are the logic for when solvers are invoked to compute adaptations and when these adaptations are applied. In this case, when the user looks around or moves, some adaptation objectives are no longer met, and the adaptation trigger invokes the solver, which finds a new solution that is applied because it improves over the previous one. Finally, property transitions decide how the virtual content properties transition to the new state. In this case, the hologram still needs to go from the previous to the new state. This can be done by using a property transition that instantly moves a hologram, or a transition that smoothly moves it over time. In contrast to using rules or scripts, specifying adaptation policies via adaptation objectives simplifies the design process. After creators decide on which objectives to use, the solver uses multi-objective optimization to find appropriate solutions, even if these conflict with each other. Using AUIT to adapt virtual elements in an existing scene is straightforward. After importing AUIT's Unity package, the creator can start by adding adaptation objectives by simply adding their corresponding script to the virtual content in the scene. Although context widgets are pre-configured for each adaptation objective, it is possible to customize the context source when necessary. Then we need to add a solver to find suitable adaptations. In this scenario, we add a global solver that can find solutions for multiple virtual elements simultaneously. Now we add the logic for the solver to be triggered and apply adaptations. In this case, the selected adaptation trigger looks for adaptations when the quality of the interface goes beyond a configurable threshold. Finally, a property transition is added so the virtual element can move smoothly and rotate smoothly when position changes. Now that all the components are in place, the creator can experience how the interface will adapt by pressing the play button. For example, if the interface is adapting too often, the threshold for the adaptation trigger can be increased. To prioritize adaptation objectives such as visibility in comparison to other objectives, we can increase its corresponding weight. To evaluate the utility of AUIT, we conducted a study with expert creators of extended reality applications. After introducing the toolkit to participants, creators used AUIT to solve 2 different scenarios. We showcase the first scenario now, which involves creating adaptations to facilitate a video call application, while an end user performs tasks in a kitchen. Participants were able to create adaptations for each scenario in less than 15 minutes that were reported to be of high quality. Creators quickly understood the design concepts present in AUIT and felt efficient while using the toolkit, considering the time spent and the result obtained. We make AUIT available through an open source Unity package that can be customized by creators to fit their needs. By making the toolkit widely available, we hope to lower the barrier for practitioners to get started creating adaptive user interfaces, enabling new workflows that allow for creativity and require less repetitive and tedious tasks.